Okay, so today we're going to still do special right triangles, but we're going to do what's called a 30, 60, 90 triangles. So one's 90 degrees, one's 30, one's 60. So we have some terminology here. So the, that's the hypotenuse. That's always the one across from the 90. And then we have the short side, which is always across from the 30, the smallest angle. And then we have the long side that's across from the 60. It will always be that way. So no matter how the triangle's turned and flipped around or whatever, the short side is always across from the 30, and the long side is always across from the 60. Okay, so 30, 60, 90 is definitely more challenging than 45, 45, 90. So the way that I remember it, it's kind of weird that they do it this way, but it's called a 1, 2, square root of 3. I guess the reason I say that it's weird is that's not the order of lengths. Square root of 3, the square root of 4 is 2. So 2 is the longest, side of the triangle, and which is always the hypotenuse. And then 1 is the shortest, and square root of 3 is the long leg, is what we call it. So we have short leg and long leg. Okay? So what we're saying is, and we always start with the short, we're always working with the short one. Okay, you're either going toward the short leg or you're going away from the short leg. Okay, but you always have to work with the short one, which is the 1. Okay, so if you're going from the short one to the hypotenuse, you're going to do times 2. And if you're going from the short one to the long one, you're going to do times square root of 3. So if this was, 4, okay, when we go this way, we do times 2, and we would get 8. And if we go this way, we do times square root of 3, so it would be 4 square root of 3. Okay, if it was 7, then this is 14, 7 square root of 3, times 2 times square root of 3. Okay, so that's the easy version of the problem. When you have the short side, that's the best case scenario. Excuse me. So this one, times, from the short side, it's times 2 and times the square root of 3. If we're going back, so the next, and so sometimes, you get your pictures like this. So the short side's the one over there on the left, and then the longer one is on the bottom. Okay, but let's say we had 10 for the hypotenuse, and we need to figure out the other 2. So we're always going either to or from the short side. You cannot go from the hypotenuse to the long side. You can't, you have to do that. There's no relationship there. Okay, the relationship is always with the short side. So if we're going backwards, then when we go this way, from the hypotenuse to the short side, we're going to divide by 2. Where it was multiplied by 2, now we're going to do the opposite and divide by 2. And then from the short side to the long side is times square root of 3. Okay, so to put it in the same kind of orientation as like the other ones, you know, I kind of turned it around. So if this was 12, going toward the short side, divide by 2, and we get 6. And then over here, we'd get times square root of 3, so 6 square root of 3. Okay, so we'll never jump from, again, the hypotenuse to the long one. All right, so, you know, if, you know, the challenge comes into play a little bit more when you have the long one, and let's say it's, well, let's do a little bit easier one. Let's say it's 8 square root of 3. So if it has a square root of 3 on it, it actually is quite a bit easier. So from that one to the short side, we are going to do the opposite and divide by square root of 3. So how does that look? Well, it actually looks very simple. Reduce, reduce, and we just get 8. Then from the short side to the hypotenuse is times 2, so we have 16. Okay, so you can reduce a square root with another square root. Cannot reduce a square root with just a whole number. So if as long as they're both square roots or they're both regular whole numbers, then you can reduce them, but you can't like mix and match it. Okay, so that should be an easier kind of problem. So the harder kind would be like if that was 9. Okay, so, well, if I go from there to there, divide by square root of 3. So 9 divided by square root of 3. Okay, so this goes back to yesterday when we had to divide by square root of 2. We got to multiply top and bottom by this whatever that square root is. So I get 9 square root of 3, and that ends up being square root of 9. And the square root of 9 is 3. So here's like a perfect example that sometimes messes people up. I have a square root of 3 and I have a regular 3. I cannot do anything with those because the square root, one of them has a square root and one of them does not. So do not do anything with the 3 that's under the square root and the 3 on the bottom. Can't do it. I could on the top up here because they both were square root of 3. But when one is and one isn't, can't do it. Okay, but I can reduce the 9 and the 3 because those are both not square roots. They're just regular numbers. So that's just 9 divided by 3, and I end up with 3 square root of 3. Okay, and that goes on the bottom down here. Okay, and then if I need to go back up, I'm doing times 2. Now it's the number in the front times 2, so it's just 6 square root of 3. Okay, so definitely harder, I think, even than yesterday, because we're having to do two sides versus just, because two of them on the 45, 45, 90 are the same. So if you figure out one, you figured out the other. You don't have to do a second like calculation or a second like, you know, square root of 3, square root of 3, or square root of 2, square root of 2 thing. Okay. All right, got another one. So let's say that that long leg was 10. Okay, so going from long to short, divide by square root of 3. So 10 divided by square root of 3 . So I get 10 square root of 3 over square root of 9, or 10 square root of 3 over 3. And again, can't do anything with the 3's there. That'll always happen though. You're going to get square root of 3 on top, and then, on this type of problem, square root of 3 on top, and then regular 3 on the bottom. And then 10 and 3 on the outsides, like I can't even reduce that. So the length of that side, as weird as it might be, is 10 square root of 3 over 3. And you can type that into a calculator and figure out the actual answer, but okay. All right, and then going from the short side to the hypotenuse is times 2, and we're just doing like the 10. 20 square root of 3 over 3. Okay, so just that top number. So it's kind of like saying, well, it's not kind of, it is like saying 10 over 3 times 2 over 1. You just have the square root of 3 part in there. Okay, so there's several different ways to kind of memorize like what's going on. There's not one that's better than the other. Like ultimately, like, you want to know like what's happening. So there's the two most like popular ways, I guess. One would be with the picture. And so we have the short one and the long one and the hypotenuse. And so, the picture one, what we're doing is like some people say, well, they go k times 2 times square root of 3, and then they have like arrows coming backwards like this and say, okay, that's divide by 2, and that's, divide square root of 3. And some people understand that and they're like, got it, I'm good. Some of you don't like that. And so what I would say is it's just kind of like if I go short to hypotenuse, I'm going to multiply by 2. If I go short to long, multiply square root of 3. If I go hypotenuse to short, divide by 2. Okay, if I go long to short, divide by square root of 3. And it's just kind of like okay, I've memorized that. Then, okay, when you go to the problem, you say, okay, what am I doing? Which one of those 4 things am I doing? And then, I'm supposed to do times 2. Okay, well, 5 times 2 is 10, or whatever like the problems are. Okay, so again, I don't know. It's an individual preference, what's going to make better sense or what's going to sit better with you. In the end, I want you to be able to solve the problem. So, not going to hurt my feelings one way or the other, whichever method you choose. Okay? All right, so I have another worksheet today, and then we'll kind of combine them all together tomorrow. All right? I hope you're doing well. Have a great day. See you tomorrow.